There are multiple bus-sized asteroids approaching Earth throughout 2025, and NASA's Planetary Defense Coordination Office tracks every single one of them. While the term bus-sized asteroid might sound alarming, these space rocks represent exactly the kind of near-Earth objects that showcase both the incredible precision of modern asteroid detection and the ongoing efforts to protect our planet from cosmic threats. Let me walk you through what's actually happening in our cosmic neighborhood and why NASA considers these particular asteroids worth tracking so carefully. When we talk about bus-sized asteroids, we're describing space rocks that typically measure around 41 feet across, though they can range anywhere from 25 to 55 feet in diameter. Picture a city bus floating through space at speeds that would make your head spin. These aren't massive world-ending rocks, but they're substantial enough that if one were to actually hit Earth, it would create quite a spectacular fireworks display in our atmosphere. Throughout 2025, several of these cosmic visitors made relatively close passes by Earth. Asteroid 2025 XF1 approached us at a distance of about 195,000 miles while traveling at roughly 8,000 miles per hour. That might sound incredibly fast until you consider Asteroid 2025 XN4, which screamed past us at over 33,000 miles per hour from a distance of just 123,000 miles. For comparison, our moon sits about 238,900 miles away, so these asteroids passed us at roughly half the distance to our lunar companion. NASA tracks these objects so meticulously because of a fundamental truth about our solar system. Asteroids are essentially cosmic leftovers from the formation of our solar system about 4.6 billion years ago. Most of them hang out peacefully in the main asteroid belt between Mars and Jupiter, minding their own business as they orbit the Sun. But some of them have orbits that bring them uncomfortably close to Earth's neighborhood, and those are the ones that keep NASA's planetary defense experts awake at night. The organization responsible for this cosmic surveillance is NASA's Planetary Defense Coordination Office, established in January 2016 with Lyndley Johnson as the first ever planetary defense officer. Think about that title for a moment. We live in an era where someone's actual job description is Planetary Defense Officer. The PDCO's mission sounds like something straight out of science fiction. Look for and catalog near-Earth objects such as comets, asteroids, and potentially hazardous objects that could impact Earth. But here's what makes this particularly interesting. The PDCO operates on what might charitably be called a shoestring budget. As of 2022, they received around $150 million per year, which NASA's own documentation describes as almost a rounding error on a federal government spending spreadsheet. That's less than what some individual Hollywood movies cost to produce. Yet this office protects the entire planet from cosmic impacts. The budget situation has improved somewhat. For fiscal year 2026, Congress allocated $341 million for planetary defense, including $300 million specifically for the Near-Earth Object Surveyor mission. This represents a significant increase, but it also highlights how seriously the threat is now being taken at the highest levels of government. Speaking of the NEO Surveyor, this represents the next generation of asteroid detection technology. Scheduled to launch no earlier than September 2027, this space-based telescope will find 90% of near-Earth objects with diameters of at least 140 meters, or about 460 feet. The mission costs an estimated $1.2 billion to develop, and its principal investigator, Amy Mainzer from the University of Arizona, pushes for faster deployment despite budget constraints. The 140-meter threshold isn't arbitrary. According to NASA's impact statistics, a direct hit from an object that large could level an entire city. Space rocks over 500 feet can cause deaths across metro areas and states depending on the impact location, and they only hit Earth about once every 20,000 years. Scale that up to a 3,000-foot asteroid, which statistically happens about every 700,000 years, and you're looking at global devastation and possibly the collapse of civilization. But let's get back to our current bus-sized visitors. Why does NASA bother tracking objects that are relatively small in cosmic terms? The answer lies in both scientific curiosity and practical preparation. Each detected asteroid provides valuable data about the composition and behavior of near-Earth objects. More importantly, tracking these smaller objects helps NASA refine its detection and prediction capabilities for when something genuinely threatening comes our way. Consider the case of Asteroid 2024 YR4, discovered by the Atlas telescope in Chile on December 27, 2024. This space rock provided scientists with what they called a tailor-made asteroid for planetary defense efforts, and an actual end-to-end exercise for how we might respond to a potentially hazardous asteroid in the future. At one point, 2024 YR4 had a 3.1% chance of impacting Earth, which triggered the International Asteroid Warning Network to issue a notice and rate it as a 3 on the Torino scale. The Torino scale is essentially a cosmic threat level system. A rating of 3 was the second highest ever reached by an asteroid, behind only 99,942 Apophis, which briefly hit a rating of 4 back in 2004. Additional observations eventually ruled out any Earth impact from 2024 YR4, but the asteroid continues to provide valuable scientific opportunities. There's still about a 4.3% chance it might hit the Moon in December 2032, which would create a crater roughly 1 kilometer wide and potentially send debris into Earth's orbit, creating a temporary meteor shower. The precision required for these calculations is absolutely staggering. Paul Chodas, manager of NASA's Center for Near-Earth Object Studies, and his team can predict asteroid positions decades into the future with remarkable accuracy. When NASA's James Webb Space Telescope collected additional observations of 2024 YR4, the data improved knowledge of where the asteroid will be on December 22, 2032 by nearly 20%. That level of precision across an 8-year time frame represents one of the greatest achievements in computational astronomy. This brings us to one of NASA's most spectacular recent successes, the DART mission. In September 2022, NASA deliberately crashed a spacecraft into the asteroid Dimorphos at 2314 UTC, successfully altering its orbit. The collision shortened Dimorphos's orbit by 32 minutes, greatly exceeding the predefined success threshold of just 73 seconds. NASA Administrator Bill Nelson called it a watershed moment for planetary defense and all of humanity. But even this success story came with unexpected complications. The DART impact dislodged 37 boulders from Dimorphos's surface, creating what researchers describe as a boulder swarm, now moving away from the asteroid. These boulders weren't scattered randomly, they clustered in 2 distinct groups, revealing that something unknown was influencing their movement. None of these boulders threaten Earth, but the discovery highlights how much we still don't understand about asteroid behavior and composition. Lindley Johnson, NASA's first planetary defense officer, emphasized that DART's success provides a significant addition to the essential toolbox we must have to protect Earth from a devastating impact by an asteroid. This demonstrates we are no longer powerless to prevent this type of natural disaster. The European Space Agency's Hera spacecraft, launched in October 2024, will arrive at Dimorphos in 2026 to conduct detailed reconnaissance and assess the long-term effects of the DART impact. Looking at the broader picture, NASA currently tracks 1,362,002 known asteroids in our solar system. In 2025 alone, there were 189 known near-Earth asteroid close approaches within 1 lunar distance from Earth. The vast majority of these objects pose no threat whatsoever. As Paul Chodas explains, the majority of near-Earth objects have orbits that don't bring them very close to Earth and therefore pose no risk of impact. However, a small portion known as potentially hazardous asteroids do merit closer observation. These PHAs measure more than about 460 feet in size and have orbits that bring them within 4.6 million miles of Earth's orbital path around the Sun. Despite the alarming name, none of the currently known PHAs are likely to hit Earth anytime soon. The detection capabilities continue to improve dramatically. The closest approach to Earth by an asteroid in 2025 was made by 2025 UC-11, which has a diameter of just 1.3 to 3.1 feet. This tiny space rock approached within 221 kilometers above Earth's surface, demonstrating just how sensitive our detection networks have become. But detection is only part of the challenge. The Planetary Defense Coordination Office currently operates with minimal staffing. Since Lindley Johnson's retirement, the office has returned to just 1 full-time federal employee overseeing fewer than 10 employees who contribute part-time to PDCO tasks. This lean structure allows for flexibility but makes it challenging to advocate for resources and expand capabilities. Congressional oversight has become increasingly important. When NASA announced delays to the NEO Surveyor launch, Congress responded forcefully. NASA's decision to postpone the launch of the NEO Surveyor to 2028 is unacceptable, came the congressional criticism. This is the only program NASA is obligated to complete by law, so this delay is particularly troubling. Amy Mainzer, the NEO Surveyor's principal investigator, defended the project. NASA's decision to slow down the funding in fiscal years 22 and 23 due to cost overruns in other missions has resulted in a delayed launch date, which pushes up the cost for NEO Surveyor, but has nothing to do with the project itself. It would cost less if we were able to launch sooner. The timeline for planetary defense is both urgent and patient. We're racing against the clock to identify and catalog potentially hazardous objects before they surprise us, yet we're also playing a game measured in geological timescales. Major extinction-level impacts occur roughly every 100 million years, while city-destroying impacts happen roughly every 20,000 years. Looking ahead, several key milestones will shape planetary defense capabilities. The NEO Surveyor's launch window opens in September 2027 with a hard deadline of June 2028. In April 2029, Asteroid Apophis will provide a spectacular demonstration of just how close these objects can come, passing within 20,000 miles of Earth, close enough to be visible with the naked eye. The recent bus-sized asteroid approaches serve as regular reminders that Earth exists in a cosmic shooting gallery. While none of these particular objects pose any threat, they represent the kind of near-Earth encounters that happen regularly and provide valuable opportunities for scientific observation and planetary defense testing. Each detection, each calculation, each successful tracking operation contributes to a growing database of knowledge about how these objects behave and how we might deflect them if necessary. The bus-sized asteroids of 2025 may not make headlines for long, but they represent something remarkable: humanity's growing ability to see cosmic threats coming and our expanding toolkit for dealing with them. As we continue to improve our detection capabilities, refine our deflection techniques, and expand our understanding of near-Earth objects, these regular encounters with bus-sized asteroids serve as both practice runs and proof of concept for humanity's cosmic defense systems. We're no longer helpless against the universe's occasional attempts to rearrange our planet's surface, and that represents one of our species' most impressive achievements in applied astronomy and planetary science. If you enjoyed this and want to see more, make sure to subscribe. That being said, I hope you all have a wonderful day wherever you are in the midst of space.